Hello, everyone. My name is Bahar Muntazari, and I am today presenting my study on treatability of industrial micropollutants by sulfate radical-based advanced oxidation processes under the supervision of Professor Edil Arslan Alaton. There are increasing concerns about the occurrence of micropollutants due to their potential harmful effects on health and the environment. Around 300 million tons of synthetic compounds annually used in industrial and consumer products partially find their way into the natural waters. Only in agricultural sector, 140 million tons of fertilizer and million tons of pesticides are applied each year. These micropollutants arrive in the natural environment mainly through industrial or municipal wastewater as a kind of the point sources or from diffuse sources such as runoff from applied field in the agricultural region and etc. Most of these micropollutants find their way to the wastewater treatment plants where conventional treatment procedures are not sufficient to remove most of them. Micropollutant consists of a vast and expanding array of anthropogenic and natural substances, such as pharmaceutical, personal care products, steroids and hormones, industrial chemicals, and pesticides. Among this wide range of these micropollutants, most frequently type of them detected in the water supplies are industrial pollutants as well as pharmaceutical compounds. These pollutants, even at trace levels, can represent serious health hazards due to their moderate bioaccumulation and high toxicity. As a result, industrial wastewater treatments are necessary to eliminate potential toxic industrial pollutant by effective methods. The low concentration of these micropollutants and diversity of micropollutants not only complicate the detection and analysis procedure, but also create challenge for water and wastewater treatment processes. Over the last year, sulfate radical-based advanced oxidation have gained notable attention due to their high efficiency in degradation of a wide variety of recalcitrant compounds and become a hot topic in advanced oxidation processes. Considering the necessary need to remove harmful micropollutants from industrial wastewater by effective treatments, the present study was aimed at investigation of the potential of one homogeneous photochemical oxidation processes named UVC, activated PS oxidation processes, and two heterogeneous catalytic oxidation processes named zero-valent iron-activated persulfate oxidation processes and zero-valent aluminum-activated persulfate oxidation processes for removal of a model industrial micropollutant named iprodium. Therefore, the first part of the study was devoted to treatability investigation of the iprodium in the distilled water, and moreover, to have a better understanding about the treatment mechanism of iprodium in the distilled water. The degradation was correlated with several important environmental parameters, such as dissolved organic carbon and amount of the oxidant consumption, that in this case was persulfate. Owing to the fact that the presence of different water constituents, such as organic and inorganic substances in the reaction system may change the performance of the selected treatment, it is crucial to examine their performance before being applied to the real wastewater. Therefore, in the second part of the study, the efficiency and the performance of the selected AOPs also was examined in the tertiary treated urban wastewater. Generally, AOPs are based on in situ formation of highly reactive species, such as sulfate radicals or hydroxyl radicals. Sulfate radicals have several advantages over hydroxyl radicals. As you can see, it is more stable and has a longer half-life time, and also these species have a higher oxidation potential. In order to generate the sulfate radicals, first we need to activate the PS by several methods, such as employing UVC light or using catalyst. Iprodion is selected as a model industrial micropollutant, and iprodion is a kind of the fungicide that can be used to prevent gray mold on the crops. The maximum concentration of 0.14 microgram per liter was reported from 12 locations in the European region, and actually because of its high long-term risk to aquatic organisms, actually its reapproval was not guaranteed by the European Commission. Let's have a look to the treatability of iprodion in distilled water by 3 selected AOPs named UVCPS, zero-valent iron PS, and zero-valent aluminium. As you can see, UVCPS treatment of the iprodion resulted in complete iprodion degradation with all the studied initial PS concentration in the range of 0.01 to 1 millimolar. The other two, heterogeneous catalytic oxidation of the iprodion, also demonstrate that both were efficient in the iprodion degradation. Zero-valent iron PS treatment resulted in complete also iprodion degradation after 120 minutes with initial PS concentration of more than 0.5 millimolar. Although the higher PS concentration appreciably improved the treatment performances and resulted in faster iprodion degradation. Zero-valent aluminium PS also was a good alternative for iprodion degradation, even with low initial PS concentration of 0.1 millimolar and 0.25 millimolar. In order to gain an insight to the treatment mechanism and examine their performance in the iprodion degradation, the selected AOPs were compared in terms of iprodion removal, DOC removal, PS consumption, and also dechlorination. As you can see from this figure, for UVCPS as well as zero-valent iron PS treatments, rapid and practical complete iprodion removal were obtained. However, the iprodion mineralization was completely different by these two treatments. As you can see here, UVCPS treatment was effective in iprodion mineralization. Around 78% DOC removal was obtained after 120 minutes, and maximum chloride concentration of 1.5 milligram was obtained at the end of the reaction. For the other two heterogeneous catalytic oxidation processes, there is unreacted PS, as you can see here. However, the partial DOC removal and poor DOC removal were obtained by zero-valent iron and zero-valent aluminium PS respectively. In order to elucidate the oxidation of iprodion in a more complex effluent matrix, those selected oxidation experiments, additional experiments were conducted in the synthetic wastewater mimicking tertiary treated urban wastewater. As you can see here, practically complete iprodion degradation by UVC was observed. However, DOC removal was limited to 24%. Most probably because of the ingredient of the synthetic wastewater might compete with PS for UVC light absorption and eventually leading to fewer available photons to generate sulfate radicals. On the other hand, complete iprodion degradation and around 40% DOC removal were obtained after 120 minutes treatment with a zero-valent iron PS, which was the most effective processes in the synthetic urban wastewater. The inhibition of the iprodion degradation in the synthetic wastewater was stronger during zero-valent aluminium PS treatment compared to the other two AOPs. So as a conclusion, three persulfate mediated IOPs, including UVCPS, zero-valent RMPS, and zero-valent aluminium PS were employed in order to investigate degradation of the protein as a well-known fungicide in distilled water as well as in the synthetic wastewater. The following conclusion could be drawn from this study. While experiment in the distilled water highlighted the superior performance of the UVC treatment, with a DOC removal of 78%, the performance of UVCPS treatment decreased sharply in a more complex wastewater matrix in the synthetic wastewater. Higher target pollutant and DOC removal rates for zero-valent iron PS was observed compared to the UVCPS treatment when applied in the synthetic wastewater, and neither target pollutant nor DOC removal was obtained during zero-valent aluminium PS when applied in the synthetic wastewater. Therefore, zero-valent iron PS can be suggested as an effective method for industrial micropollutant removal. However, if we recommend this treatment, we have to consider the need for pH adjustment for inacidic pH, as well as the concentration of the iron release, as well as sulfate ion release. Thank you for your attention.